Simple stress and strain. Simple stresses and strain. First of all, what is there are you know that first of all, if the load, if the external load that will act on any structural member, what will happen? Suppose, for example, a column is given, an external load act on that column. What will happen? Some stresses induced in that column. Okay, means that it will depends upon the properties of that material which is made. Before starting a new chapter, simple stress and strain, we have to understand some mechanical properties of the material. Uh, I will tell some property that is elasticity, plasticity, ductility, brittleness, hardness, fatigue, creep, toughness, yield, fatigue, endurance. These are some of the mechanical properties. And according to that properties, the behavior of material will happen or will occur according to external load acting on that. Then here, first the concept, that is what is stress. First of all, stress is a, suppose this is a specimen, this is circular bar or rod. What will happen? Two equal and opposite force or load will act on that bar. What will happen? The stress will be induced at any section in that bar, like this. Means that if the two equal and opposite external force act on that bar or specimen, the stress will be induced at any section, which means that the internal resistance force developed per unit cross-sectional area. The stress, which means that the internal resisting force means that material will resist to each other. Means you know that the material which is made by infinite number of small particles, and that particle resist to each other at that section in the opposite direction to each other. Means that the stress, which means that the internal resisting force developed per unit cross-sectional area, that is said to be stress. Stress is represented by mathematically sigma, that is equal to P upon A. Unit is Newton per mm square. That is said to be stress, which means that the stress is defined as the internal resisting force developed per unit cross-sectional area, that is said to be stress. Mathematically, stress is represented by a Greek symbol sigma, that is equal to P upon A. Unit of sigma, that is Newton per meter square or Newton per mm square. Okay, that is very simple concept of stress. Types of stress, there are different types of stresses. The first is direct stress, then tensile stress, normal stress, shear stress, then normal stress, which means that tensile stress and compressive stress. Direct stress, what is direct stress? Direct stress means the load whose line of action coincides with the axis of member. The stress induced in body, that is said to be direct stress. For example, suppose this is a column. Then load will act. What will happen in the opposite direction? The stress will generate. Means that the direct stress is defined as the load whose line of action coincide with the axis of the member. The stress induced in it, that is said to be direct stress. Direct stress is a that stress will induce throughout the centroid of the section. Then um, normal stress. Normal stress, there are two type of stress: tensile stress and compressive stress. Tensile stress, which means that if two equal and opposite types of stresses, direct stress, normal stress, shear stress. Okay. Direct stress, normal stress, and shear stress. Direct stress, what is direct stress? Already discussed. The load whose line of action coincides with the axis of member. The stress induced in it, that is said to be direct stress. Normal stress, there are two types of stresses: longitudinal or tensile stress and compressive stress. Tensile stress, what is tensile stress? Suppose this is a specimen and equal and opposite pull force will act. What will happen? The it will change its length. Okay, it will change its length. Suppose this is original length. What will happen? There will be change in its length. Length will be extended. Okay, if equal and opposite tensile force or pull force will act on that specimen, there will be change in length. The length will extend. Then stress induced, such a kind of stress is said to be tensile stress. In the same manner, we see compressive stress. Compressive stress, which means that if two equal and opposite push force will act, what will happen? If two equal and opposite push force will act, there will be change in cross-sectional area of that specimen. That area will either reduce or increase. Means there will be effect on the cross-sectional area of that specimen. Means that if the two equal and opposite push act on that bar, there will be change in that area. Then shear stress. What is shear stress? Shear stress, that stress, if two equal and opposite force will act in opposite direction, what will happen? Means the one means there will be change in cross-section surface area. Means that, for example, suppose the braid and it will cut by knife into slice. What will happen if the direction of cutting of braid by knife from top to bottom, what will happen? The shearing occurs between the two cross-sectional surface area. The first surface area is blade and second will be knife. For example, suppose this is the blade, for example, and it will cut by knife in that direction. It will cut by knife into size of the blade, the direction of force from top to bottom. What will happen if the cut of slice of the blade into pieces by knife? If the direction of the force from top to bottom at that time, what will happen? The shearing occurs between the two surface area. This is the surface area of the blade and the knife. Okay, shearing occurs between the two surface area of the body, and at that in that situation, what will happen? The shearing occurs, and that is said to be shearing stress. Shearing occurs between the two cross-sectional surface area. Shearing stress, which means that force per unit area, that is the same as the stress. It is shearing stress is defined as the shearing occurs between the two cross-sectional surface area, then stress induced unit, that is said to be shear stress. That are the types of the simple stresses. That is direct stress, normal stress, and shear stress. Then we see what is a direct load. Okay, one concept is remaining. What is direct load? The basic concept is same. The direct load, which is defined as the load whose line of action, coincide with the axis of the member, that is said to be direct load. Means that it is that type of load which act through the centroid of the section of the body. Then what is eccentric load? Second, eccentric load means the load whose line of action do not coincide with the axis of member. For example, column, okay, that load will act away from the center of the column. Then in that situation, what will happen? The eccentricity will occur between applied load and distance, which means that the eccentric load, which is defined as the load whose line of action do not coincide with the axis of member, that is said to be eccentric load. And that eccentric load will always be act away from the centroid of that section. That is the difference between the direct load. Direct load means that load whose line of action coincide with the axis of the member, that is said to be direct load. Direct load always act at the middle or centroid of the section of the body, and eccentric load will act away from the centroid of the section of the body. That is the basic difference between the direct load and the eccentric load. So that is very important concept from the stress point of view. The stress induced in direct load, that is said to be direct stress or axial stress, because that stress will generate throughout the centroid or throughout the middle section of the body. And that's why that is said to be direct stress. Then we study different types of stresses, that is direct stress, normal stress, and the shear stress. Then the next thing, normal stress always act at the 90 degree to the plane of the section of the body. Means that suppose the specimen which is placed in horizontal position, if we pull and oppose it, a tensile force or pull force will act on that specimen. What will happen? Or normally stress will be generated at any section of the body, and that stress will be normal or 90 degree to the plane of that section of the body. Means that the normal stress, which means that normal stress generally occurs in the tensile and compressive nature of the load. Then here, before studying the basic concept of the stresses, we have to understand the one more concept, that is the strain. What is the strain? The strain is defined as the ratio of change in length to the original length. It is represented by small t. Particularly, suppose this is a specimen, and if load will act at the middle, what will happen? There will be change. Suppose length L of that specimen. What will happen if the vertical external load will act on that specimen? What will happen? That specimen will extend beyond, that is represented by delta L. Means that strain is defined as the ratio of change in length to the original length. Delta L upon, it has no unit because it is a unit less quantity. It has no unit. Strain has no unit. Always remember, very very important point. Strain has no unit. Okay. In the same manner, we also discuss different types of the strain. The first is the simple strain. Second is lateral strain. Types of strain. Simple strain, lateral strain. What is the simple strain? What is the lateral strain? That is very important concept. The simple strain we already discussed. The ratio of change in length to the original length, that is said to be simple strain, which is represented by small e, that is equal to mathematically delta L upon L. It has a unit less, or it has no quantity, or it has no unit, because the unit of L is, for example, meter, and unit of delta L is also meter. Meter cancel, then it is zero. It has no unit, and that's why strain has no unit. Then second, what is lateral strain? The change in lateral dimension to the original lateral dimension. That is said to be lateral strain. Yeah, for example, suppose a cube, okay, it has a three dimension: length, breadth, and height. What will happen if the tensile, suppose the external tensile load will act in the direction of length, particular dimension, then according to definition of lateral strain is defined as the ratio of change in dimension to the original lateral dimension. Change in dimension means length will also change, it will elongate, but the lateral two dimension is also affected, that is height and width. If the external tensile load will act along the direction of length. The other two dimension will also change. Change in dimension to the change in lateral dimension means other two dimension means delta V upon V, that is equal to delta T upon T. Okay. Third dimension is suppose thickness. It has a thickness. Means lateral change is defined as the change in lateral dimension to the original dimension. Means that change in lateral dimension to the original dimension. What is the meaning of that? Change in lateral dimension means suppose the body which is in cube form, it has a three dimension length, width and thickness. If the external tensile load will act at one end of the body, that is cube, what will happen? There will be change in the lateral two dimension to the original dimension. Means that the external load will act, that is tensile load will act. The change in lateral two dimension, that is width and thickness, change in lateral dimension to the original dimension. Original dimension is T and V. Lateral strain, which means that the ratio of change in lateral dimension to the original dimension, and that ratio represent lateral strain. Then delta B, that is equal to B, that is equal to delta T upon T. That is case for a cube. Okay. But if the another example, that is circular section, the nature of body or section of the body which is in circular form, what will happen if the external tensile load will act on that circular section of the body? Suppose bar. Okay. What will happen? Load will act, external pull or tensile load will act at one end of the bar. What will happen? There will be change in lateral dimension to the original dimension. Lateral dimension, circular has only one dimension, that is diameter, steel. That is D. Okay. Change in lateral dimension delta D upon the original dimension. Means if the case of the circular section, what will happen? The change in lateral dimension to the original dimension, the ratio of change in lateral dimension to the original dimension, that is said to be lateral strain. It is represented by EL, that is equal to delta E upon D for circular section, and for cubic delta L, that is equal to delta E upon D, that is equal to delta E upon D for the cube section. Okay. Then that is we discuss two type of strain. Simple strain, the ratio of change in dimension to the original dimension, that is E is equal to delta L upon L. Then lateral strain, which is defined as the ratio of change in lateral dimension to the original dimension. That is, there are two cases. That is, first case is the section which is in cubic form. It has three dimensions: length, width, and thickness. And second, we see the section which is in circular form. It has only one dimension, that is the diameter. And in case of cubic section, lateral strain EL, lateral strain is represented by EL, that is equal to delta B upon D, that is equal to delta T upon T. And if the section which is in circular form, it has only one dimension, that is diameter. EL, that is equal to delta D upon D. Okay. Then next is volumetric strain, change in volume to original volume. If the body which is in cubic form, you know that it has a volume of any cubic section, that is L into V T or H. Then the product of three quantity, then we get volume of that section. Then volumetric strain, that is defined as the change in volume to the original volume, delta V upon V. That is said to be a volumetric strain. Very simple way to define volumetric strain, which is defined as the ratio of change in volume to the original volume. That is, mathematically it is represented by EL, that is equal to delta V upon V. Then next one is shear strain. Shear strain, which means that if we apply shearing load, suppose this is the body, if you apply the two equal and opposite of force, one will act at the top of the layer, then what will happen? The shearing will occur between the two cross-sectional surface area. One is table, the other is body, and that will act in opposite direction. If two equal and opposite tensile load will act, if one load will act at the upper face of the layer, that is rectangular section, one will act at the upper side, what will happen? The shearing will occur between the two surface area, cross-section surface area. One is table, other is body, that is rectangular body which is placed on that table. Then shearing will occur between the two cross-section surface area. That is, one surface area is table, other is body. Then shearing will occur. Shear strain will occur between the two cross-sectional, means shearing will occur between the two cross-section surface area, and at that time shearing strain will be induced. Then this is very simple way it is represented by phi, shearing strain. The next concept we study, elasticity. What is elasticity? If the external load will act on the body at one end of that body, the body will change or body will deform, that is change in shape and size, and after removal of the external load, body regains to its original position. That property of that material is said to be elasticity. But in opposite case for plasticity, if the external load will act, what will happen? The body will be deformed, but that deformation is permanently. That body is permanently deformed. It will not back to its original position. That is the differentiate between the elasticity and plasticity. In case of elasticity, what will happen? If the external load, either push or pull, will act on that elastic material, that body which is made, what will happen? The body will be changed in its shape and size, that is, the body will be deformed, and after removal of external load, body regains to its original shape and size, means body regains to back to the original position. But in the opposite case, controversy regarding the plasticity, but in case of plasticity, it will be completely opposite thing. If the external force act on that plastic material, there will be change in shape and size, but that changes permanently. Body does not regain back to its original position in case of the plastic material. That is the difference between the elasticity and plasticity. Elastic material and plastic material. That is the nature, that is the property of that materials. Elastic material and the plastic materials. Clear? Next, what is Hooke's law? Hooke's law, which means that within the elastic limit, the stress is directly proportional to strain. Is say within the elastic limit, within the load which is act within the elastic limit, the stress is directly proportional to strain. Stress is represented by sigma that is equal to strain. Then the constant of proportionality, that is for Young's modulus of elasticity, because there are three elastic constants: Young's modulus of elasticity, modulus of rigidity, and bulk modulus. These are known as three elastic constants. Then within the elastic limit, Hooke's law, which states that within the elastic limit, the stress is directly proportional to the strain. Mathematically, it is represented by sigma that is directly proportional to E. Then we have sigma that is equal to T into E, capital E, which represents Young's modulus of elasticity for that material. That value will be 2 into 10 raised to 5 Newton per mm square. Now, what is Young's modulus of elasticity? Young's modulus of elasticity, which is defined as the ratio of stress to strain. That ratio is known as Young's modulus of elasticity of that material. It is represented by capital E, and the value of the capital E of any material is constant 2 into 10 raised to 5 Newton per mm square. That is very, very important value while solving any kind of problem which is related to the Young's modulus of elasticity. If that value is unknown, if that is not provided in the problem, that is always assume that value E is equal to 10 raised to 5 Newton per mm square. That is very, very important value. E is equal to 2 into 10 raised to 5 Newton per mm. And Young's modulus of elasticity, which is defined as the ratio of stress to strain, that ratio is defined as Young's modulus of elasticity. Okay, that is very important concept. Young's modulus of elasticity of particular material, of any kind of material. Then that are the few things we study. It has been studied in that chapters. Then in the next lecture we discuss some numerical which is based on that concept, that is stress, strain, yeah, particularly. Thank you.